Sunday, huh? Thomas? Thomas. Sunday?
Yeah.
What's Sunday?
So we're now at 22.
Hey, that's my lucky number.
1, 2, 3, 4, 1, 2, 1.
Oh, no.
Alrighty. I have no idea what to say, so let's go. Anything before 47?
You can tell he knew. That's what we're going to say.
37? Which one's 37?
Lottery.
Lottery? Lottery. You're welcome.
53 numbers.
Huh. We haven't done that one today.
Asleep.
47.
I was like,
Oh, 47 was the one you said first. That's Survivor. Oh. Survivor's a lot easier than you think. So 6 people are left. 1, 2, 3, 4, 5, 6. Right? You know how the premise of it? You're voting out somebody. You're trying to vote somebody out of the game. Who are you not going to vote for? Yourself. So therefore, how many options do you have when you vote?
5.
5. How many options do you have when you vote? 5. How many options do you have? 5. 5. So 5 to the 6th power. 15, 6, 2, 5, I believe. Right? Right. Survivor on you. 37. This is an easy lottery, actually. 53 numbers, just picking 6. So it's not, there's no Powerball on top of it or anything like that. It's just 53 and 6. Is it a permutation or a combination? It's a who? Combination, because the order does not matter. It doesn't matter whether it's 1, 2, 3, 4, 5, 6 or 5, 2, 3, 6, 4, 1. It makes no difference. You still win. So it's a combination of, who's you? 53
And 6.
picking 6. You got it. Okay? Yeah. Okay. I had a bloody nose today. It's weird. Bye. No. I was sitting in 3rd hour class. And actually, I was walking around going to help somebody. Sniffled. Sniffled again. What? Blood everywhere. Did I what? Did I just gushing all over the floor? And people were like trying to step out of the. Yeah, it was bad. Just kidding. Bled for about 2 minutes, 3 minutes. What? 43.
These are
That was one of second in line.
oh.
March Madness. March Madness, you're
got
starting
in.
with 64 teams. They want to know how many of the teams, or how many options there are to get 16 teams in the Sweet 16. So, no. Eventually they would get to the Final Four, but they asked how many would get. Gotcha. So it's simply C 64, 16. Okay. Others?
57.
That's the one that I was thinking was 47.
Oh, yeah.
What's the 7?
That was cold.
Page 10, number 6.
No ASMR on my YouTube channel.
Anyone know the relationship between CNR and CNR minus 1? R minus 1? Plus 1. Plus 1. Okay. When they say relationship, what they really mean is ratio. They basically want a fraction of the first one over the second one. Okay? So that's what they mean by relationship. All right? So don't overthink this at this point. If you had to do something here, what would you do? I mean, this is going to be this isn't like a one-step problem, right? Well, what if we do the formula? You know what I mean? I mean, how would you find the combination of something? I mean, does this R mean a number? Well, no, it means all kinds of things. It means factorials and numerators and denominators and stuff like that. So if we said C8(5) over C8(3), what does that mean to you? Well, I know what it means to me. Nothing. I don't know what all this stuff means. So what are we going to do with it? Well, we got to get it to the point where it means something. And how can we get it to mean something?
Equation.
Plug in the formula. So tell me what to write. N factorial over n minus r factorial times r factorial. That's C and R. Okay? Go. N factorial over n minus r plus 1, right? So n minus r minus 1 factorial times r plus 1 factorial. Okay, just grind some things out for a while. At some point, we'll have to do something, but hopefully that'll be at a point where things make more sense. So, what does all of that mean to you at this point? Still nothing, I would agree. So, is there anything that we can do? Can we? My answer to that is I don't know. Because what does this mean to me?
Nothing.
Nothing yet. So we have
Equation.
we have a fraction divided by
A fraction.
a fraction. If you have a fraction divided by a fraction,
Multiplication.
multiply by the reciprocal. So, n factorial over n minus r factorial times r factorial times n minus r minus 1 factorial times r plus 1 factorial over n factorial. Okay there? All right. Next step. Can we cancel the n factorials now?
Yes.
We absolutely can. Okay? Bless you. I wasn't sure if we could before, and if we did, we're canceling numerators, and it just makes me nervous. So, but now I know we can. So we can zap that and zap that. So that's good. Okay? So we're here. Does this mean any more to us than it did before? Well, something clicks to me a little bit. I think we did this the other day. So let's see if we can use something here. What's r plus 1 factorial? Let me rephrase it. What's the first term in r plus 1 factorial?
R plus 1.
R plus 1. Right? What's the first term in 8 factorial? 8. Okay? So r plus 1 factorial is going to be r plus 1 times r times r minus 1 times, or in other words, r plus 1 times r factorial. Because remember, we can put the factorial in anytime we want. Is that helpful to us?
Yes.
Why?
Because there's another r factorial.
Because there's an r factorial over here. So so now, oh, these are canceled, so those are just ones. All right, so we got that. And we got the r factorial there, so that's going to be helpful. What about the other stuff? The n minus r minus 1 factorial and the n minus r factorial. Why did we do this one? Right, but why did we start to crank out this one as opposed to this one? Because this one was higher? So if we're going to do the same type of thing with this, which one's higher?
The bottom.
The
Denominator.
the n
Minus r.
n minus r factorial. So let's play with this one. What's the first term of n minus r factorial?
N minus r.
N minus r. What's the next term? N minus r minus 1. N minus r minus 1, and then we can go factorial on that, right? Yeah. Up here we have the n minus r minus 1 factorial, and got stuff we can do. So what do we do?
Cancel.
N minus r minus 1 factorial, n minus r minus 1 factorial,
R factorial.
r factorial, r factorial, which gives us r plus 1
Over.
over n minus r. Can we cancel the r's? No?
Yeah.
Why not?
Being added.
They're being added and
Because they're being
subtracted.
added and subtracted, therefore, that's our answer. Bless you. So, you guys were looking for a shortcut here. Whoever was first bathroom-wise, you can go. I don't remember who was first. You were second, I think. Who asked me? Who said after 10 minutes can I go?
I did.
You did.
Yeah.
You asked me twice?
Well, I asked.
No, it's fine. I'm just, okay, yeah, go. I'm sorry. So you guys were looking at this, going, all right, can I cancel this or can I multiply? Wait until something actually means something. You know, was the first step a big deal? Going from here to here? No, because you just used the formula. Was it a big deal going from here to here? I mean, all we did was flip the bottom and multiply, right? So this wasn't a big deal. The biggest issue that we had was writing this factorial as n minus r times n minus r minus 1, and r plus 1 is r plus 1 times r factorial. That was the biggest deal. But if you shut it down right away, you know what I mean? If you start looking at it going, what's the answer here? You know where I'm coming from? Grind it out, crank it out, use the formulas, do what you got to do, but don't assume that you can make adjustments just because some things, I mean, we don't know what combinations do. You know, we wrote it over here. What did I write? C8-5 and C8-4 or something like that? Yeah, I mean, what do we know about them? Not much. So crank it out first. You can do this stuff. Yes, sir.
How did you get the n minus r minus 1 in the bottom?
Right here. Well, we said n minus r factorial is n minus r is the first term. Then what's the second term? 1 less than that. So n minus r minus 1. That's where that came
I got the top.
Good. Okay. Okay. Time to move on. Yeehaw. Okay, last section in the book. This is it. This is the last section in the book. Section 12.7. Right, if you flip the page after 12.7 is done,
It's all gone.
get to some review exercises, a cumulative test, and then the answers.
But then we skip like 5.
We skipped.
Our homework is going to be on page 1158, and the answers start on 1169. Wow. We did it. We did the whole book. Not really. Not yet. All right. So we're going to talk probability today. The first phrase we're going to talk about is called sample space. Sample space. And sample space is very simply the list of possible outcomes of an event. So if we are to flip a coin, the sample space is
2.
not the number of outcomes, but the list of outcomes.
Oh,
Heads
tails.
and tails. So if we flip a coin, the sample space is heads, tails. If we roll a die, that's our die.
One
Okay, dice is plural, so 2 or more dice.
is a
1
die.
die. Got it. If we roll a die, what is the sample space?
1, 2, 3, 4,
1, 2,
5,
3, 4,
6.
5, 6.
So you said a die.
A die. You could roll dice,
That's 2.
but the only problem is we don't know how many. You could roll 2 dice or 5 dice or 27 dice. I don't know.
Oh my God.
Dice just means more than one. It would be like saying person and people.
You only say die when
You wouldn't
there's
say
one die.
27 persons.
Huh?
All right, if,
Die.
now, if we flipped a coin and rolled a die, what would be the sample space?
Heads, tails, 1, 2, 3, 4, 5,
Okay.
6.
Yeah. Heads, 1.
Oh.
Heads, 2. Right? It's a list of all possible outcomes. So we're not going to make you write all kinds of possible outcomes. That would be busy work, I think. But just understand what sample space means, because I'll use that phrase a couple times today. So the sample space for rolling a die and flipping a coin would be heads 1, heads 2, heads 3, heads 4, heads 5, heads 6,
Tails 1.
tails 1, tails 2, tails 3, tails 4, tails 5. How many elements would there be in the sample space?
12.
Why? Why 12?
You do it 2 times 6.
2 from the coin, 6 from the die, and we multiply them. Why do we multiply them?
That's how you combine.
Fundamental counting principle, you got it. Okay? Sample space, done. FCP? Fundamental counting principle. Probability. The probability of an event happening is the number of ways the event can happen divided by the number of total possibilities. So if we're going to roll a die again, and we ask what's the probability of rolling a 4, how many ways can we roll a die and get 4? One way, we roll a 4. How many total possibilities are there?
6.
And so the probability of rolling a 4 is 1/6, which you knew anyway, I think. Okay. But now we're going to take it and go with it a little bit. Let's say we're now going to roll 2 dice. There's 2 dice. There we go. All right. I want to know the probability of rolling 2 dice and getting a sum of 5. Sum of 5. A sum. S-U-M, not S-O-M. So, how many different ways can we roll 5?
2.
Give me the first way.
4 and 1.
1 on the first die,
4 on
4 on the second die.
4 on the first.
2 on the
3 on
first
the
die,
3 on the second.
3 on the second die.
And then
4 on the first die.
3 on the first die,
2 on the
2 on the second
2 on
die.
the second die,
4 on the
4 on the first die.
first die,
1 on the second die.
I very strongly suggest going in order. It makes it less possible to miss something. How many different ways can we roll a 5 on 2 dice? 4 ways. So the number of ways that we can roll a 5 is 4, over the number of total possibilities is 12.
12.
36. Because there's, no.
How many options are there on the first die?
6.
How many options on the second die?
6.
Oh, 6.
What do we do with those 6s?
Come.
Why do we multiply them?
Put a third one.
Fundamental counting principle, FCP, right? So, 36, think of it this way. You could roll 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. 1, 3, 2, 3, 3, 3. You with me here?
Yeah.
So it's going to be 6 times 6, which is 36. Now the answer to your next question is yes. We do need to reduce it and simplify it, whatever. 1 line. So the probability, if you roll 2 dice, of getting a sum of 5 is 1/9. Okie dokie. Okie dokie. If you roll 2 dice, what is the probability of rolling a sum of 7? Same thing? Still 1/9? Why not? Different ways to roll 7. Okay. Tell me about them. 1 and 6. 2 and 5. 3 and 4. 4 and 3. 5 and 2. 6 and 1. That's it? So therefore, how many ways are there? 6 over 36. Still 36 possibilities when you roll 2 dice, which can be reduced to 1/6. Probability of rolling a 7 on 2 dice is 1/6. Is equal to what?
The probability of rolling that single number on
That's true. And he's saying it's the same as this. Rolling a 7 is the same as saying what's the probability of rolling 1 die and getting a 4. Because 1/6 is 1/6. He says they're the same. I get it. And here's the reason. Because 7 is the only number, if you roll 2 dice, 7 is the only number that no matter what you get on the first die, you can still get 7. You can still get that number. Right? Like if you're talking about rolling 5, and on the first die you roll a 6, it ain't happening, right? And if you're trying to roll a 10, and on the first die you roll a 2, it ain't happening. So, but if you roll a 7, no matter what you roll on the first die, you can still get 7. Make sense? What's the probability of rolling 12?
Probably. It's all way 6. It's like one way to get 6.
There's only one way to get it?
There's 2 ways.
2 ways.
6 and 1
Technically, are they different?
That's like a double T.
Probability of rolling 12.
Gotcha.
I feel like it's one.
One way. If you roll a 6 on the first die and a 6 on the second die, is there any other way that you can roll 12? No, that is it. 6 on the first die, 6 on the second die. That is it. 1 out of 36. That is your answer. What is the, what'd you say? Same with 2. You got it. 2 and 12 have the same probability, 3 and 11, 4 and 10, 5 and 9, 6 and 8. Craps. It's craps in Vegas, at the casinos, rolling dice. Craps. C-R-A-P-S. It's a dice game that they play in casinos. Everybody yells and screams all the time. There's more excitement at a craps table than any other. Don't know why.
Is that the one where like bombs people?
Yep. Because I don't have time today. Remind me, maybe tomorrow, I'll explain the craps to you. The reason that there's so much yelling and screaming at a craps table is because, for the most part, if one person wins, everybody wins. It's not like blackjack where you win but he loses, and he wins and he ties and stuff like that. It's everybody's in it together, so they yell and scream. You know, one person wins, and the roller throws the right number, and everybody wins, and so everybody yells and screams. What is the probability of rolling 13?
0.
Okay, impossible. I need something besides a word. I need a
Out
number.
of 36.
Number of ways that it can happen?
0.
Over a number of total possibilities.
36.
0 over 36 is
0.
0. The probability of something that cannot happen is 0. Makes sense, doesn't it? What is the probability if you roll 2 dice of getting a sum that is less than 20?
1.
Why?
Because every time you do it,
How many different ways can you roll
30,
a combination that is under 20?
36.
All 36, right?
Yeah.
So it's 36
Over 36.
out of 36, which is
100.
1.
So 100%.
As a percent, what is 1?
100.
100%. So that kind of makes sense. What's the probability of rolling a sum that's less than 20? Well, 100%. Makes sense. So the probability of something that is guaranteed to happen is 1. Something that cannot happen is 0. Something that's guaranteed to happen is 1. Okay? Okay. Remember what's next. Oops. So, let's assume for a second that if you have a child, the probability of a boy and the probability of a girl are the same. They're both 50%. Okay? What is the probability if you have 2 children that they are both girls? So there are a few different ways that people start to think about it. And if you start to think about it, most likely you're going to go in a bad direction. So what I would suggest doing instead is writing out the sample space. If you have 2 kids, what are the possibilities?
Boy, girl.
Boy, girl,
Girl, girl.
girl, girl,
Boy, boy.
boy, boy, girl, boy. Fair? How many ways can the event happen?
1.
1, that's the only one, right? How many total possibilities are there?
4.
1, 4. What if it were 3 kids? Probability of all 3 girls. Do not forget
1, 6.
FCP.
Fundamental counting principle.
Never called it FCP before, but just figured I'd go with it. If it were 3 kids, what would be the probability of getting all girls?
8. 1 and 8.
1 in 8. Why 8?
Because 2 times 2 times 2 is 8.
Fundamental counting principle. 2 options for the first child, 2 options for the second child, 2 options for the third child. 2 times 2 times 2 gives us 8. And the only way of getting all girls would be girl, 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 so it would be 1 out of 8. No? girl, 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 boy, girl, boy, girl, girl, boy, 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 girl, girl, boy, girl, boy, boy, boy,
Girl.
girl, boy, boy, boy. That's it. Those are the possibilities. Fair?
Yeah.
How many of them are all girls?
One.
One. How many total did we list?
8.
8. There's your 1/8. But the reason it's 8 is because there are 2 options for the first child, boy or girl, 2 options for the second child, 2 options for the third child. So 2 times 2 times 2, we knew that there were going to be 8 possibilities. Does that make sense? What if I asked what is the probability of having 1 girl out of 3? You have 3 kids. What's the probability of having 1 girl? 1 girl. Let's see. 1 girl.
Oh, just
1
one girl.
girl.
Oh, 2.
1 girl. 1 girl.
3 8s.
3 8s. That's why some of these things you got to be a little bit more careful. You can't just go, well, let's see, 1/8. Probability of 3 girls is 1/8, so the probability of 2 girls is 1/8. The probability of 1 girl is 1/8. The probability of no girls is 1/8. There would be a problem there. That would only be 4 8s. You know what I'm saying? So in a case like this where the sample space is easy to write, sometimes it's good just to write the sample space. And then it becomes a lot easier to see what you're looking at. Okay?
Yeah.
Questions there? In here they have an example that's similar to ours from yesterday. What is the probability of not winning the lottery? Except they had a very simple lottery. Yeah, they had a very simple lottery. They said it's going to be 1 to 49, and just pick 6 numbers, 1 to 49. I know, much better. So their number of possibilities was 13,983,816. That's easy, I know. And yet still, so the odds of winning are 1 in 13,983,816. So what would be the odds of not winning, the probability of not winning?
Whatever it is, 13 million, whatever it is, minus 1.
1 minus. Yes?
1 minus.
Yeah.
Why
Minus.
would it be that minus?
Yeah, would it be the
Well, because
number of solutions minus 1?
over,
Yeah.
yeah, which is the same thing.
All right.
So the
Over your.
probability of not winning